It opens the file and we see some vectors and equations. And at this point, I will take screenshot. We can go to full page and zoom in and do some basic measurements and calculations. Here you should be able to see the option to select ruler, and the ruler you can rotate and read the angle on it. So for example, when we align the ruler with the vector, we get 27 degrees. The number is there only when you keep both fingers on the ruler. During the adjustment, you see the updated value. Once you let go, it disappears. You can go and see that 0 is horizontal, and if we go below the x-axis, it's still positive, so be careful about that, because in physics that would be minus 16 degrees, and in this case it's still 16 degrees below horizontal. This would be 16 degrees above horizontal. So when we measure some length, we align the ruler with the vector, and then we just draw a line. And here we see the value 3278. If you go back, it doesn't change, so that's good. If you make it longer, it will change. So it's good to try once, twice, just to see if you get roughly the same value. So 3278. We can write it down. U is 3278 units long and 27 degrees in first quadrant. The first number is the magnitude of the vector, call it U, and the second number is the polar angle, and we call it theta. We'll use those two numbers to predict the x component and the y component. The x component, ux, will be the u times cosine of the polar angle, and the y component is u times sine theta. Now the horizontal component will be somewhere here. Y component is over here, and we can start with the measurement. So the horizontal line is roughly 2936, and the vertical component is about 1458. Now we have to take our calculators and see what are the predicted values. So using 3278 and cosine of 27 gives us 2921. So that is the x component, and the y component is 1488. To summarize our findings, we can look at the numerical values and the measured values. So the black colored values are measured directly from off the screen, so measured in black, versus calculated values are in red. and we can look for the percent difference between those two values. So the x direction leads to about 0.5%, and the y direction, that one is about 2% off. So 1458 versus 1488, the relative difference is 2%, and here's why. When I designed this picture in GeoGebra, my choice was 30 units in x and 15 units in y direction. That's in Cartesian coordinates. Here was in polar coordinates. Now, how do we get the angle? Well, there is easy formula. Theta is tangent inverse, we call it arctangent, of the y component. So we can write y over x, and that is 1/2, so tangent inverse of 1/2 is about 26.6 degrees. And that explains why the measured value is smaller, because it corresponds to smaller angle.